The gear-driven, self-powered permanent magnet generator was invented by engineer Rufino Rafi Alberinian, the chairman and CEO of Ryanix Wendelcy Energy Corporation. He started working on the invention early in 2014 with the assistance from USA business and financial advisor L3D International by Lynn Williams in Australia, David Grant, and David Bailey in USA. In early 2020, his classmate Rizal June Kamanian initiated and requested him to make a prototype generator with a capacity of 81 kilowatts to the lowest capacity at an affordable cost. Thus, we came up with a 2.2 kilowatt drive motor to drive the first gearbox high-speed RPM with low output speed and coupled to the second gearbox with low input speed RPM and high output speed RPM, and the output shaft of the second gearbox is coupled to the shaft of the permanent magnet generator to drive the whole system with a capacity of 12 kilowatts.
The invention is not only unique, it is also peculiar. It is a small input which drives a bigger output. It is self-powered with a performance efficiency of 95% and operates 24/7, 365 days with no brownout or blackout. The main purpose of the invention is to help the aching environment. It will help clean our surroundings of polluted air so that we can breathe clean air again. Green our fruit trees and vegetable plantations, help lessen the negative effects of global warming and climate change, and it will put to a stop the supply of fossil fuel stuck to the existing power plants. There will be no need to pass on the cost of the power to the consumers, thus helping the needy.
Employees affected by the shutdown of the fossil fuel feedstock will be accommodated by Ryanix Wendelcy Energy Corporation. The produced green energy power of the Ever motor can be installed in the existing fossil engine power plant and connected to their substation at a very low cost power rate. Allow the fossil engine power plant to distribute the power according to their power purchase agreement without any escalation of the cost per kilowatt hour.
The gear-driven, self-powered permanent magnet generator invention is designed as a manually controlled generator with automatic controls over a complete electrical safety and instrument process controls, providing easy operations and monitoring of all the parameters in the control panel and in the control room. Our innovation is called Gear-Driven Self-Powered Generator or Ever motor. It is a small input which drives a bigger output. It is fuel-less as it is self-powered. The source of the power initially coming from either wind, solar, or battery backup inverter with 220 to 380 volts and 60 Hz. After 5 to 10 minutes of stabilizing the operations, the speed, current, and frequency of the standby power will automatically disengage and the Ever motor will power back to the drive motor. At this stage, the system will power by itself for 24/7, 365 days without brownout or blackout.
The 2.2 kilowatt drive motor with a speed of 1,750 RPM coupled with the first gearbox with high input speed RPM and with low output speed RPM. The output speed of the first gearbox is coupled to the input shaft of the second gearbox with low input speed RPM and the high output speed RPM. The output speed of the second gearbox is coupled to the permanent magnet generator with a capacity of 12 kilowatts, which is the speed is lesser than the speed of the output shaft of the second gearbox RPM to compensate adjustment if there's a friction when the system operated. The speed, current draw, and frequency is controlled by the variable frequency drive inverter instrument with complete electrical control interlocking system for the safety of all the equipment installed. The commissioning and series of testing, each testing operating for a minimum of 4 hours, were witnessed by a bank manager, a bank marketing manager, and their classmates of batch 75. The testing started on July 27, 2020, using the biodiesel standby generator. August 15, 2020 to August 16, 2020, utilizing the first variable frequency drive inverter with 220 volts input and 380 volts output. September 10, 2020, the arrival of our order of the second variable frequency drive powered by itself, witnessed by Bonel Balinggit, the former Philippine Basketball Association superstar. In September 15, 2020, witnessed by the owner of water concessionaire Abejo Water Corporation and their engineers. September 17, 2020, witnessed by the East-West Marketing and Bank Manager. October 7, 2020, witnessed by the owner of Sacres Machine Shop, Mr. Arnel Sacres and his engineer. And on October 12 to 13, 2020, witnessed by the President and CEO of Gin Lodging Mining Corporation, Mr. Jet P. Tupas, and together with his two colleagues.
Engineer and our electrical supervisor and our mechanical engineer. So this purpose of this prototype is only for the approval of patent. So this is we call it, our innovation called it gear-driven self-powered magnet, permanent magnet generator or Ever motor. Okay, so I think we will start. Derek will take over.
Okay. Good morning, gentlemen. Welcome sa Alubinsan. And
Alubinsan, pinungungahan ni kay Boundary man.
okay, we welcome also the Abejo Waters Corporation. We want to present the innovation, and hopefully we could offer solution for the needs of Abejo. So, let me introduce myself. I am Mr. Derek Radasa as Marketing Director of Don Carbo Ryanex Energy Corporation now. Among i-present ang innovation. This is called, as the chairman says, Ever motor. So it's a hybrid self-power generator. So una akong kuan nga kini siya, this is a 2.2 kilowatt motor. So ang iyang i-powered is the generator, which is 12 kilowatt, meaning we will be starting this motor or pagagana ni nato ni nga motor with the power requirements of 2.2 kilowatt. Now through this gear, kaning first gear, dawato no gikaduhang gear. I will not disclose the mechanism of this gear for now, since this is one of our secrets of this innovation, because the invention starts from here and it ends here. So kay kining motoran is existing on the market na, the generator is existing on the market. The two gearbox are kuan siya kanang, this is invented by our chairman, Mr. Barinian, no? So normally, as the plan goes, kinigid siya later on, kung mag-commercialize na ta, iso di siya og container. Pag na-containerize na siya, air condition, ang mag-powered ani, it's the generator itself, no? So, for now, since we are waiting for the battery, ang mahitabuan niya, ang external power na to sa Veco, or Veco, sorry, mo power ani niya. So, pag patuyok ani niya, dire, dawato na ni nga gearbox, madaog na niya kay kung kini siya nga motor ato ning iditsog kopo diri under no circumstances nga matuyok gini niya kay tako man kay ni siya di gini siya kahimo, but because of these two gearbox mao ni maka using this one, the demand of this motor naka-produce ang generator of times 500% of the capacity sa kuan sa starting motor, no? So pag ni-start na ni siya, this is 2.2, this is 12 kilowatt. Pag dagan ini, dagan na rin. So this is producing 12 kilowatt or ano na siya. So ang 2.2 mubalik diri, i-disconnect na yung automation na gi-set up ni siya para mubalik diri. So nang ay surplus nga 9.8. So mao na nay atong i-feed dito sa grid or sa mga building or sa mga planta nga na-require power requirements. So we can increase later on the capacity of generator and the starting motor, no? So karon atong sugdan ang atong demonstration. Unang-una naani siya gitawag og variable frequency drive to kuan siya to start ani niya para mag-adjust sa iyang RPM, no? So ablihin lang sa ninyo. Hello. So nana ni siya kanang set up nga og na-stabilize na ang supply diri. Makuha na ni siya, makuha na nato ang external power source. Power by itself, tapos pasigaon nato ang atong mga power demand. So, let's start with kuan lang muna, minimum lang usa. Okay. Ipakita ko sa nila nga kini, suppose this is battery but we are using the external usa just to initiate. Sige. Okay, as you can see, ako kayo difference diri slow kaayo ang revolution niya, but here kusog kaayo ang yang RPM. Now, as I have said, kung idiretso na nimo di gina siya pwede. Bugat kaayo ni siya. So, but because of this, napatuyog nato ang 12 kilowatt nga generator.
Okay. Alright.
Okay,
di lang ikaw ka
so, karon makita na to nga external pa ang power ani niya, no? So, once ma-stabilize ang pag-distribute sa production sa energy, ato na siya ibalik niya diri, i-disconnect nato ang external. Okay, change Okay, sige. Okay, sige. Okay.
Ang output,
Power ni dali.
kawero ni sa kini. Kini pan.
Blower.
Ina ko already na para tangtangon na to ang external source. To demonstrate na wala na. Pan.
Alright, andar na.
Okay. Ang fan kani is independent motor ni siya. So, for now, ang power produced by the generator, ang power niya, ang fan pa lang sa, no? So, karon pag stable na, let me know, kay disconnect na to ang external source with to show them na recirculating ng energy. Okay, tangtang na ang external source para makita na to. Namamatay na ang BFD. Okay, ito lang. Okay.
It will take 10 minutes ha.
10 seconds. Kaya siya, mamatay na siya. So wala na yung external source. Ang mag-power by itself, ano siya, deploy na lang is. Pero currently, ang tagaan na to with load, wala na yung external. Deploy na lang. May mga tagaan na to, kasigaan na to, may kasigaan na siya. So, hinahinay ha. Okay. Initial, tagay ko sa load. Ang basketball court na. Basketball court. Okay, tanawag ni Siga mga kuwan sa basketball.
Okay, sorry.
Okay, next stage. Dili tag 500 watts siya ang kuwan. Okay, next Siga. Okay. So, magpasabot kini siya. This is purely green energy. Wala na dito tuyot na lang ni siya. Wala tayo fuel consumption.
Sir. Oh, bali power by itself na siya, sir.
May kuha ni siya, nga ni-generate ka lang ni siya, niya, patuyok, ang surplus mo yung atong bitasiga, ang kadasugaan ni is 500 watt, isira.
Pupuntahin niya.
Oh, sige, sarado lang, sarado.
Three piece. And then the front of the motor goes
Oh, Jinsit ko. Jinsit ko. Oh, Jinsit ko.
duha man 220 right to neutral and then ang 3-phase 380. Output niya is 380 and 220. Neutral and line 1 that is 220.
Yan o, Jinsi, hindi mo guys yan, madami kasi kayo. Kita ba nyo, 2.2 kilowatt ang iyang nameplate. Pero, naman sa record ang 12 kilowatt.
Sige, picture lang tayo kami. Yan ang nameplate sa kwan.
0 to 1,750 RPM. This is 2.2 kilowatts, which is coupled for the first gearbox, which is the high speed, and the output is low speed, and then coupled to the second gearbox, which is low input RPM and high output RPM, which is coupled to the generator, which is 12 kilowatts. So the 2.2 kilowatts will drive the 12 kilowatts. No? So it is very big difference. We call this inhibition is a gear-driven self-powered permanent magnet generator. Small input drive the bigger output. We call it is our Eber motor. Okay, we will start. Our starting point is we have to use the electric cooperative, the Civico. Just only for start. There is the control of this one. We have a variable frequency drive, 0 to 60 hertz. Iwan lang daan. Okay. Start mo na yung inverter. Start mo na yung inverter. Okay. Just slowly ang kwan. Okay. You can see the difference. This one is low speed and this one is high speed. Sila ka frequency in may kwan. Hindi siya magbabay dito. Kuwan pa nimo dito. Pwede na. The first power which is supplied from the generator is the blower, which is this one is different motor. It is 380 volts. So, anda na? Saya padali mo. Kanin mo. Anda na. So, next is to this will be take over, the power will take over. Ito, sino? very minimal lang ang noise. No? Very minimal noise. So, you change over. So, this one now is powering by itself. So, ang power, get out the power from the Sibico. Wala na power na Sibico. So, this one is powered by itself na siya. Okay. So, we put load. Dili na atong load. Okay. Ato ang ilaw na. Gari ka naman. Sige na. So, ang power it is only recycling, which is purely green energy. Okay, so the next one.
Ako lagi ito.
So this one is already 24/7, 365 days.
Kim.
No burnout and blackout. Okay. Ito, kung saan yung kaya natin sa lapat na sabihin
The operator started the innovation. The display video showed the difference of the speed of the drive motor coupled with the first gearbox output shaft and the second gearbox input shaft. The speed of the permanent magnet generator is lesser RPM and the speed of the gearbox number 2 is higher RPM. Thus, the set point is set at 80% so as not to overspeed the permanent magnet generator. When the system operation was stabilized, we tested the load capacity of the permanent magnet generator. We powered up the lighting, the basketball court, and some appliances in our residence. The system operated smoothly, and we declared our innovation is successful as it has been proven that a small input 2.2 kilowatt asynchronous drive motor can drive the bigger output 12 kilowatts permanent magnet generator, is powered by itself and runs indefinitely.
As shown in the video, the control panel has a push button for the start and stop of the ever motor, light indicator, voltage indicator, and frequency indicator. When the operator starts the system, the variable frequency drive inverter is powered by the battery charger DC-AC inverter. At this stage, the starting power source is coming from the battery bank or off-grid. Once the variable frequency drive inverter is light up and ready to operate, the operator will adjust the speed of the asynchronous drive motor until such time the speed, frequency, and voltages is synchronized. The power from the permanent magnet generator will provide the power from the battery charger, and this will automatically charging the battery, and after the battery is fully charged, the battery is in standby mode and the system is powered by itself for 24/7, 365 days with no brownout or blackout. The next stage, we are going to develop a showcase of the innovation for a bigger capacity for the commercialization process. The 45 kilowatts drive motor will drive the 280 kilowatts generator. The 100 kilowatts drive motor will drive the 650 kilowatts generator. The 250 kilowatts drive motor will drive the 1000 kilowatts generator. The 500 kilowatts drive motor will drive the 1250 kilowatts generator. 650 drive motor will drive the 3000 kilowatts generator. The 1120 kilowatts drive motor will drive the 5000 generator, and the 1200 drive motor will drive the 6500 generator. At this point, Engineer Rafi would like to acknowledge the contribution of his children. Ryan Barinian, who is also an engineer, helped with the technical works, and Onyx Barinian, who is the pilot, helped with the review and evaluation of the technical processes. Thank you.
So we have our innovation. My classmate June is our president, and then Roland is our instrument manager, and our instrument engineer. So our innovation scope is gear-driven self-powered generator, which is small input drive the bigger output. So first, this is a 2.2 asynchronous motor, 2.2 kilowatt asynchronous motor, which is coupled with the first gearbox. And then the output of this gearbox from high speed to low speed, and then from low speed to high speed, and then drive the 12 kilowatts. So the 2.2 kilowatts will drive the 12 kilowatts. So we have already the controls here. When this one is running, so we have a voltage line 1 to neutral is 220 volts, and we have a 3-phase. So dalawa ka kuan niya. 380 volts, 3-phase. So ang power in the because to make it pure green energy is to use the startup, use the wind, solar, because I'm also a wind developer, the lone wind developer here in Cebu, in South of Cebu. I have a project which is 2,000 megawatt from Argao going to Badyan. That one is we finished already our feasibility study, and hopefully we can kick off before end of this year. And then we will retrofit for this our innovation. Okay. So our power, starting power, either wind, solar, or standby generator, or the battery backup. But for the meantime, we will use first the Sibico power. Okay, we will start. Okay, when we plug this one, so the power for the external power that will be like on.
Nagipit na, Jet,
So, ang power gikan sa external power sa Sibico. That is to start. So, the control of this one, there's a variable frequency drive, which is 0 to 60 Hz. And this one is 0 to 60 Hz and then 0 to 380 volts. Start the first inverter. So you can see the speed. This one is a low speed and this is a high speed. So when it will be synchronized. If the box goes to 220 and then it is 380, so we can now change over, which is it will power by itself. So this is the sequence. If this one, the other variable frequency drive will stabilize, it will be take over. The generator will power back to this motor and then it will recycle the power. Okay. And fan motor, you start the fan motor first because this one, this is different motor. Okay na? So this is the first power from the generator, which is 380 volts, the fan motor. It's okay now. Okay, you change over. Okay, you take it out the bolt so that if this one will okay on. So no more external power. So this one is recycled the power. So now we put a load. First is the basketball court. Okay, we start the basketball court. Power supply siya.
Yung start up, pag ganito yung drive. Dito yung mag-start up ko na.
Ito ang mag-drive. Ito ang iniikot. When the generator turn, so it will produce power. Because of this two gearbox, so nakaya. So this is 500 watts. Yung isa. So, ang power gikan na sa generator. No? So, 12 kilowatts minus 2.2, mayroong surplus siya na 9.8 kilowatts. So, baon na ni power niya. Ang dito lang may grounded, so very sensitive ang amuang kwan. Variable frequency drive, so it will trip. So our model for this one, we have 5.5 kilowatts drive, the 20 kilowatts, and then 10 kilowatts drive, 30 kilowatts, and then 25 kilowatts drive, the 50 kilowatts, and then 45 kilowatts drive, the 280 kilowatts, and then we have 60 kilowatts drive, the 350 kilowatts, until 6.5 6,500 kilowatts. Yun ang model na mo sa one for the commercialization process. This one is only for a proof of concept for approval of our patent. So that's why we have some already ordered some showcase for the ice plant sa Consolation and Mandawi. So kung if you want to work with us, we can. If you need 1,000 kilowatts, so I have to double it. I will install 2,000 kilowatts para spare yung isa. Spare. Kailangan mayroong spare siya so that it will run 24/7, 360/9 without one breakdown. Kasi if there's a preventive maintenance or sudden breakdown, maka-kick-in na yung isa. We have a load sharing and load shedding controller that will be automatically kick-in. Parang wala siyang drawn out. welding machine?
Yes.
Oh. 380 na linya. Kailangan siya 380, 3 phase. So my choice, so 20 or 380. So, 3 phase na ako siya.
Ilang kilowatt na siya? 2.2 kilowatts to drive the 12 kilowatts. Pwede niyong videohan niyo. Kita niyo. Pwede niyong videohan para makita niyo dahil there's so many engineer here, electrical engineer, and then pinadala namin ng video. So 18% yung para sa deployed. Bali, Juan, 20% input niya, ang output niya is 80%. So, yun ang iyang ratio niya. Small input drive the bigger output. Monitor, and then powered by itself. Wala na, natutulog lang siya. So, wala na isugrod na kuwan. So, purely green energy, power supply siya.
Yung start up, pag ganito yung drive. Dito yung mag-start up ko na.
Ito ang mag-drive. Ito ang iniikot. When the generator turn, so it will produce power. Because of this 2 gearbox, so nakaya break, so the other one will recover.
In a one, in a situation na ang lugar, for example, island, wala tayong isip, basta may time start na ba?
Oh, the start is the bank, as what I told you, we have a battery bank start up that is off grid. So we will start, and then we will start, so the generator will power back to the motor. It will run. Battery what siya, bank. Battery inverter, which is, the battery is 480 volts DC, and then there's an inverter which is converted to 380 volts to run the motor. Very simple lang. Walang complication siya. Ang kuwan lang, question lang nung i-double din siya. Damay siya din. Dako. That's why small input drive the bigger output and it will power by itself.
Matulad, ilang kasako na kuhan, power, ang kasako na.
Yes. It is typical. Typical lang. So, for example, you need 60 kVA. So, ang kuwan yung 60 kVA din ang gawas niya, output niya. This one we can put it in containerized and then in 1 megawatt is only, we need only 100 square meter.
One container yun, sir.
Ha?
Ilang container? Containerized ito.
I-containerize yung system nga, doon ka container kasi na.
1 megawatt.
1 megawatt.
May size ko ito niya.
Mga 20 footer.
20 footer.
Wala ka 20 ko ito.
Oh. Sunod kasi, gawin mo ito. Maximize ito. Ang feeling ko rin yung bagay talaga. Kasi kasi diba, ang speed low speed. So high speed.
There are 4 one speed combination. Kini siya high speed ni siya, kini high speed din pero mas ubos ni siya. Kini ubos kayo. Kini siya ubos kayo. Diri one shot parehas diri high. So parehas di kailangan na they will synchronize. That's why we have a variable frequency drive to control the speed. 12 kilowatts to 6,500 kilowatts.
So this is contribution also for our environment, for our global warming and climate change. That will become base load. Wala na siya intermittent. Which is figure 3 in our patent, and a hook-up drawing which is figure 6 in our patent, which is beside in our control panel. In our control panel, we have an indicator which is voltmeter from the genset line 1 to neutral, that is 220 volts AC. And then there's another one which is 3-phase, 380 volt AC. So this is a voltmeter, and we have a drive motor current draw, which is indicated for the current, and then the kilowatt hour and the watt hour. So for this one, first inverter when we start, so this one will on. This first inverter will on, and then the second inverter, this one is indicator also, and we have a fan motor indicator, because the fan motor is different from the one hindi butang sa outboard bearing ba.
Pero
Siya.
kuan siya independent siya pero naa siya sa motor gihapon.
Nasa sa motor, yes.
Ah,
Yes, yes.
okay.
Nasa sa motor.
Okay.
So, and we have, kasi pwede aplihan kasi. We have two inverter. First inverter is for the start up from the external power, and the second inverter is the takeover of the generator power. So this is our magnetic contactor, and then we have a single phase circuit breaker and the 3-phase breaker.
Single phase sa imong kuano?
Ah,
Startup.
ang start up is 220 volt, and then the output of the inverter is 380 volt.
Okay. Nganong line 1 naman to? Para kakuha kag kuan.
No, this one, maybe.
Oh, line 1.
This one is
Genset
the
line
indicator, which is the genset line 1
Neutral.
neutral to 20 volt AC. But we distributed it to this one, KM3, KM4, KM5, distributed for the load. So this the one distribution, which is line 1, and then line 2, line 3 to equal the load. And then we have a 3-phase, which is the power for the motor, and then to take over the motor, that is 3-phase. Okay, so we start. We're using the utility provider, which is the Civico.
Civico for starting.
So only there's no power yet. When we start this one, there's no power. Okay, so when we use only the plug-in, and then we have an outlet there, so that this only one will power up. Okay, you plug-in type lang. Just only to show that there's a power. Okay, there's an external power ready before. Okay, you start.
Okay, 1.
Yeah. See, you can see it is a low speed and also high speed. So this is 2.2 kilowatts. Coupled with the first gearbox and the second gearbox, and drive the 12 kilowatts. So this is now power coming from the external. So you start with the fan motor. You see the fan motor is running. You see, it's running now. Because we have already 220 and 380 volts. Okay, we can now start to up.
Yaon tong isang inverter daw.
When this one,
Ilan na? 3
we set it at 80%.
Okay.
80% checkpoint. So, and it is synchronized. So, we will change over.
Ano ka synchronize yan eh?
Oh,
Ako na, synchronize na.
Synchronize na.
Inverter to inverter lang.
Oo,
Okay, pwede mo.
okay.
Ito naman eh. Snap.
Yes. Okay. So, you take it out, the power from the Civico. So, no more power from Civico. So, it will take 10 seconds to set up this one.
Masyad ko pala siya.
Oh, 10 seconds to set up. Just need to
Automatic.
prove, yeah, just need to prove that there's no more outside. So, no more power. So, the power now is recycled. Oh, because we have a power here.
Kita na na dire.
Yes,
Andar mo ni Bay. Gikan nga ni, andar mo na dyan ni.
Gikan dito.
Ikan dire. Dire mo itatang power.
Oh. Okay, we will
Ano mo
put,
siya drive?
load.
Dire ang discount.
First load. Oh, see? Oh,
Pag-id ko kamay, no?
Wala siya load.
Check up na lang.
Okay, kasi na yun. So, yun. This is only, simple lang. So, when we shut off this one, we just shut off this second inverter and all will off. Gikan man dire. Oh. So,
So katong inverter mo na taga-control sa imbutahe pag ipagawa mo. Kaya 380 man to sa inverter.
ang inverter nag-control siya sa iyang speed niya so that yung frequency niya na ma-maintain niya na maka-build up niya nga ang output niya is still 380 volts.
Sir, ang behavior ano yan, motor load na.
Kumbing at easy that the one take over to supply the 2.2 kilowatts. And we have a variable frequency drive. We have two variable frequency drive. First is for the startup, and then if it is synchronized, it will be take over of this one. So you put a power. So this one, no sound sa.
Power
This one,
from Civico.
wala talagang power to it. There's no power. There's no power here. So because there are some coming here and engineers, so maybe this one there's some magic way to running. So wala yung power. So you plug-in type lang. Oh, we have already power here. Okay. So we start the first inverter. So there's already a power of the first variable frequency drive. So now it's running. This one is low speed, and this one with high speed. And you can see the voltage goes up. So when that one is stabilized, we will own the fan motor. So this is the fan motor. We have already 220 volts. We have already 380 volts. So the fan is running here. So you can feel the fan may blow na siya. Blow na siya. Okay. So we have already a power of the second inverter. So this one will synchronize. This one is set to 80% set point. So after synchronization, we will take over the power from the Civico. So now, yes, synchronize na. Okay, good. Okay, no more power.
Wala na
More power. So, the power now is recycled. The power now is coming from here. Feed to it that 220 volts. 380 volts AC. And then, we put a load. Oh, that's a 500 watts each bulb. 500 watts. The second. Oh, so, ang basketball court, di natin kuwan kay wala na siya kuwan ba. So, the noise is very minimal only. Sige na tanan, so ang power ano gikan hindi wala na tayo gasto. Itantang naman si Biko. Lumod. So this is the only why I'm using the 2 gearbox. This second gearbox is to transform the speed to drive the 12 kilowatts, because if this 2.2 kilowatts we direct couple it to the 12 kilowatts, dili ka kadaog. Cannot be, there's no circumstances that will be told trip din na siya. So but because of this one, so the invention start here and in here. This one is given already. We can fabricate any kind of capacity, and also the generator. So very simple lang. So our model for this one, so I need 3 million pesos to purchase the demonstration, the mobile demonstration unit, which is 5.5 kilowatts drive 20 kilowatts, and then the next is 15 kilowatts drive 55 kilowatts, and then all of our model until 6,500 kilowatts. So that's our model. I already completed the design, and we have already an agreement from the manufacturer to purchase this one. So we started this one July 27. Wala may breakdown. Still working. But this one is only for the proof of concept for our patent approval. Yun ang mga requirement. Very simple lang. Yeah, if we will off this one, only the second inverter will start, and then all will shut off. Because the power is coming from here. Patay ka na. Oh. So yun. Just how simple is that? This is called Bird Ribbon Shape Power Generator. Small input drive the bigger output, and this will power by itself. But first, we will use first the Civico for the starting up. We have 4 variable frequency drive here for the start, and then for the tip over, which is powered by itself. So now we will start. So you can see now, it's slow motion, and then this is high speed, low speed. So this is 2.2 kilowatts, drive the 12 kilowatts generator, which is the 2.2 kilowatts was coupled with the first gearbox, which is high speed to low speed, and then the second gearbox from low speed to high speed, and then connect to the 12 kilowatts drive generator. So now we have already a power which is 220 volts and 380 volts, which is the output of the generator, which is the line 1 and neutral 220. L1, L2, L3 is for the load. So now we have also a drive motor current through. So we have now 6.9 amperes, which is this is 1.83 kilowatts and 2.3 watts. So now we will start the fan motor. So because the fan motor is different, because this one is a synchronous motor and this one is induction motor. So now it is running. So you can see the air flows. Right? So now we are going to take over the power from the external power. Okay,
No, di ka kaku.
sorry. Tik lang. Di, wala kong ulang Sorry, because it was the second inverter is not synchronized. Okay, you start again. you can see here, when we start this one, so this one is set to 80%. So now it is running. Okay, now we have already 220 volts here, 380 volts here, so we have to start the fan motor. So the fan motor, so there's already a power from the second inverter. So we have to start the power inverter. After synchronization at 80%, we have to take over. Okay, now the power now is coming from the generator. We have to take it out, the external power. See, okay. So no more power for the external. So this one will take 10 seconds to off. When this one is off, so no more power, external power. The power now is coming from the generator and it will go cycle. So now we will put a load. This is already purely green energy. Okay. So the other one, so there's already a power. So the 12 kilowatts minus 2.2 kilowatt, that is 9.8 kilowatts, the surplus, and then minus the performance efficiency, so meaning 8.9. So this is the one we're going to. So to make it sure that this one, there's no magic, because somebody said that there's a magic. Because when I off this one, all will off, and you want power. This one will go down, this one will go down also. So I off this one. Oh, see? Oh, no more power. So the power is coming from here. That's the beauty of this innovation, which is power by itself. Small input drive the bigger output. Yan. Bank and it will power by itself. This one is called gear-driven self-powered generator. Small input drive the bigger output and it will power by itself. So meaning this is 2.2 kilowatts motor, drive motor, and then coupled with the first gearbox and the second gearbox and drive the 12 kilowatts. So at 2.2 kilowatts, this will drive the 12 kilowatts. So this is our single line diagram, which is submitted to the patent, which is video 3, and this is hook-up drawing, also submitted to the patent. So this one, there's no power yet, even we start this one, so no power. So the initial power is coming from the Sibico.
Gion na ni mo noy? O pa da noon.
So we have two inverter there, the variable frequency drive for the first, for the start up, and then when it will take over, so we have another one. So we plug in this one. So there's already a power here. There's already a power, which is the external power Sibico. So when this one is running, so we have output of the generator, which is line 1 and neutral 220 volts. And then we have a 380 volts also output. And then we have a drive motor carrying through. So this one, when we start the inverter, so meaning there's already a power in the inverter. So it's running now. Now it is running. This is low speed and this one is high speed. So we will see this one. So it's already 220 and 380 volts. So we can do take over the power. So meaning we'll start with the fan motor. The fan motor is different motor. Now the fan motor is running, right? change over.
Uy. Saka.
Una ni mo, kasi ito ko speaker din. Saan yung karimini ko? Yung. Okay, we'll start again. Now it is running.
Ito na lang.
We have to start the fan motor. Okay. Now, that's really a power with we will wait for this one to synchronize. If this one is at 80%, so we have to change over. When this one is changed over, this one will off and the second inverter will on.
Engineer there.
Okay?
Sa'yo.
Take it out this one. So now, the power is coming from here and then this one just only recycle now. It is recycle. Now we take it out the power. So no more external power sa Biko. This one will off after 10 seconds. So after 10 seconds it's already off. So meaning there's no more external power. So it is in the internal power coming from the generator and power by that one. So this one is recycled. So now at 2.2 kilowatts, 12 kilowatts, so the 12 kilowatts minus 2.2, so that is 9.8 kilowatts remaining power here. Okay, so it goes to the 2.2 kilowatts there. So now we will put a load. See, this is the power now coming from here. Okay, so another load. So that is the power now coming from the generator. So we will not on this one because it's raining and grounded. So this is how simple we do our innovation. Our innovation by design is from 12 kilowatts and then 20 kilowatts up to 6,500 kilowatts that can be retrofit all the wind power project here in the Philippines. Even the fossil engine, coal-fired, we can retrofit it. We can put the power in their own substation. So this is the purely green energy power supply, which is also can help and one of the solution to the global warming and climate change. Because this is purely green energy. The power is coming here and then powered by them, and then the 12 kilowatts minus 2.2 kilowatts, that is 9.8 kilowatts. So minus the performance efficiency, which is 95%. So it will put 8.9 kilowatts. So this is the one with power. This is the power now. So when we start, I will re-off this one so that we will know that no more power. So if I will off this generator, so all this one will off. We just simply off the second inverter. All the power is off. So this is my invention, which is I submitted my patent last December 23, and with the help with the financial advisor from Australia. So they finance the equipment, plus my classmate June Kamangyan also financed the impact. So this is now we're going to commercialize and then install all over the place. So if our government will not help me, maybe I will export it to the other country, and then if I have money, I will come back. na the supply. This is 24/7, 365 days without burnout or blackout. This is the design of this one. So my design is up to 6,500 kilowatts, which is small input drive the bigger output. The 6,500 kilowatts, it is 2,500 kilowatts motor drive the 6,500 generator. So that's the one. And then the surplus will be fed to the grid. That's the one. We can make, it is unlimited. We can supply unlimited. In either we can replace the, only we would like to stop the fossil coal-fired power plant. So the coal only will be taken out. The facilities will use it. We will feed it to the grid, and then they will distribute the power which according to their power purchase agreement. So I go down to 2 pesos per kilowatts. I can go down to 2 pesos per kilowatts, so that all the power supply, our electricity bill will constant. Wala nang pataas, wala nang pababa, hanggang dyan na lang. Gusto ko, sa kuan, kung ibawa ka sa Aln Builders, Aln Waste to Energy, which is in Binalew, nagpirma namin ng 1,200 kilowatts na isyukis dito sila, which I know that in Alugin Sanson sa naasab. Kaya in Waste to Energy, wala dili gina istorya lang ng kuan, Waste to Energy. Dili reliable because the feedstock wala jud. Butbot. So pagurot sa parang renyo, Waste Energy, pagurot sa waste, hindi mo naman ba? Oh. Model pa niya. This, kabali no? This is totally a solution for the global warming and climate change. This is to help our environment. I developed this one for 6 years, no? 6 years develop na ko, so na pandemic lang muna nadugay. So it's so happy lang nga kanisang punduan ako operator, PWD siya. Alupin lang sinako kay dual impact naman ko. Senior citizen ang PWD pa to. I have 40% one discount. For our patent. So this is our innovation, which is 2.2 kilowatts. Drive the 12 kilowatts, which is the 2.2 kilowatts coupled with the first gearbox, and then connected to the second gearbox, and then drive the 12 kilowatts generator. So this one is variable frequency drive, and then we have another fan here, and then when the system will start, so the output of this one has two output, line 1 and line 2, line 3, which is 220 volts, and the other one is 3-phase 380 volt AC. When this one is running, so this volt will go to 220, and then this one 380. So we have two inverter here, variable frequency drive. Which is the first inverter just to need for start using the external power supply, and the second one is the takeover of this one and then power to the drive motor, and then that will be changed over. Okay, so the load is, we have a load here, basketball court lighting load, and then genset in-house lighting load, and genset in-house lighting load 4. So we have 6 bulb here, which is 500 watts each. So this one is already 3 kilowatts, and the other one there in the basketball court, there's another 2 kilowatts, plus the 2.2 kilowatts, which is powered back to the motor. So that will become 8 kilowatts, plus this one here, power the electrical control panel and the inverter. So, John, okay, we will start. When we start, we just use the outlet and the plug from the Civico. So, hold on. First, so there's no power here to make it sure. There's no power here. No power. So, we just own the power from the Civico. So, we have already a power, external power from Civico. So, we can start the first inverter. So the first inverter has already power, so we'll just start this one. This one set to 80%. So you can see here, it's very low speed, and here is already a high speed. Because this one is 188 RPM, and this one is 1200 RPM. You can see the voltage, there's already a voltage here, 220 volts, and this one is 380 volts. So meaning, there's already a power which is 380 volts. So we start the fan motor. So the fan motor is independent. So this is the first power coming from the generator, which is this one. So we have already a power here. So we will, the second inverter should be synchronized at 80% set point so that it will take over. Okay, we take out the power from the Civico. So no more power from the external power. So this one will off after 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no more power from the external power. So this one is now gadagan. Just only recycle, the power recycle. Okay? So the power now is coming from here, which is completely independent. So we put a load. So there's a load already. This one is coming from here. Okay? So another load. So this is the load now. It is purely green energy power supply. Wala tayong wag isugnot.
No fuel.
No fuel.
Ilan na megawatts ron? Nagdagan? 3,000?
This one is already 5.2 kilowatts plus 1 kilowatt there. This is 6 kilowatts plus if we will own this one there, so that will be the 8.5 kilowatts. So this is the only now it will run for 24/7 and then 360 days without burnout or blackout. Our model here, the next is 5.5 kilowatts, drive the 20 kilowatts. That is for our mobile demonstration unit. The next is 15 kilowatts, drive the 55 kilowatts. And then the 20 kilowatts, drive the 80 kilowatts. That one is up to 6,500 kilowatts. So that is our model. So we can retrofit all the solar and wind power, even the coal fire. We can stop their feedstock and then we let them distribute our power supply. Because this one, the next is we will use only a charger inverter with battery bank. So no more external power. So even we are in off-grid, so we can start without any power supply. That's only independent power supply. I completed or designed up to 6,500 for this one, but the patent we just only submit last December 2020. So we are protected for 18 months for the application of the patent prior to the approval. So we will stop. If I will stop this one, so everything will stop because the can diri sa kuan sa generator. So when we stop the second inverter, all will stop.
and then we can start it again. Saksak mo. We start it again. And you can see this one is slow moving because the variable frequency drive will slowly goes to 80% set point. So you can see it's very slow first. Until here, you can see the voltage here is going up. And after reaching 220 and 380 volts, we can start the fan motor. So the fan motor is already powered here. Init. Init pa di ay. Musigan na siya. Taot-taot. Kaya nagsuloy man eh. Init pa ang kuwan. So, more simple na kayo. This one is a customized because this one is we already customized. This one, the invention start from here and end it here. Because this one also is customized. 12 kilowatts only 2.2 kilowatts.
So, kasabot na dadaling secret recipe.
Nara dire.
Gearbox.
Oh. So mo na lang kuan. Kaya sa tong banana ko nimo na kuan. So this is principle. So pagka kuan na dagpo na ibutang na to ni sa kuan in 12 because in the solar we need in 1 megawatt we need 1 hectares. In wind we need 2,400 square meter. But this one in 1 megawatt is 100 square meter only. 100 square meter. You can put only the 1 megawatt you can put on the 12 footer container. So mauna.
So, 10 footer or 12 block?
Okay. This is 2.2 kilowatts drive motor. This is asynchronous drive motor which is 0 to 1,750 RPM. Which is coupled to the first gearbox which is high speed and low speed. And then coupled to the second gearbox which is low speed to high speed, and then coupled to the generator which is 12 kilowatts. So the 2.2 kilowatts will drive the 12 kilowatts. So after this one, when it will run, so this one will take over, the power will take over, and then it will power the 2.2 kilowatts, and it will become recycled, and then the what do you call this one? The surplus will be powered. Yun ang i-concentrate. No? This one is a separate motor. The blower is separate motor. It is 380 volts AC. Okay? So, this blowing, I posted it here, is the one also, this is a single line diagram which we submitted into the packet. This is figure 3 and the hook-up drawing is figure 8. So now, our power supply is coming first to the one. From the Cibico power supply, the provider, the electric providers, and we have two variable frequency drive. First is the one that start the motor, and then after synchronization to the other second inverter, this will power this one, and then after synchronization, this will be take over. The power will take over, and then it will just only recycle.
No Civico.
No more Civico. We have to take out the Civico.
Alright.
Okay, so
Wala na kuryente.
this is the
Wala.
external power. So when we plug in this one, naka-plug na ba, naka-on na ba dito? Tingnan nga dito sa kwan.
just only use the outlet and the
Kumo ang outlet. Residential lang.
siya lang, yeah. Yeah. Just only for starting and then
Right.
it will
Start lang, pag paon.
yes. So walang power now. There's no power of this one because there's so many engineers here. I think there's a magic why this one is running. So even we start this one, there's no power. No power. Una. Okay. Okay. You plug it. Yeah, you just only show it that there's already a power set. There's already a power.
External.
External power. Okay. First, you open it this way.
Hindi ko pa
You start the first inverter. Green lang. So it is running. Here is very low. Low revolution RPM and then high RPM. So after this is a voltmeter which is the output of the generator, you know. So this is line 1, line 2, line 3 and neutral, that is 220 volt AC. And in this one there's a 3-phase 20 volts. So now is 3-phase. So we start the fan. So the fan motor now is running and then we after synchronization, it will, because the set point in this one is 80%. So that it will be synchronized. After the synchronization, this will be take over. So now we take out the power from the Zibico. So no more power from Zibico.
Hallelujah.
So the power now is in the cycle. No? So this one 12 kilowatts minus 2.2 kilowatts. So the load. So this is the load 6.36 ampere and then that is 1 kilowatts. And then there is 7 watts upstairs. So now the 12 kilowatts minus 2.2 so that we have 9.8 and then minus the petrol efficiency so we have 8.9. Completely independent na eh. Independent na. So we will put a load. A load na ta. Oh, so this one is 500 watts each bulb. Okay. 1,000.
Wala yung dagdag na ito dito.
Next.
Wala yung dagdag dito.
So, ayag na kayo. Ayag na. Oh. Actually, ang basketball court sa ito, napulod pa. Pero, napulan mo ko pagka mag-retso. So, just only to make it sure this one is running, we will stop and then we will start again so that you familiarize the sequence. Okay, because this one, the 2.2 kilowatts, if we put the one directly here, hindi ko makaya na ito yung pagay. Right? Because of this two, so this one is customized and also this one is customized and this is the one with the invention is here. This two here. Okay. So just to make it so satisfying, wala nang talagang power. So ang power na rin nag-power na siya.
24/7.
24/7.
365, no brownout.
So, if I will stop the second inverter, ganito lang siya patay. Kaya, dili magkita ang kuwan. See? Tayo tanam.
So, wala yung problema.
So, we will start again. Kaya, wala na power, oh. Wala na power. Oh. Ito. So, saksak usap.
Sikit ko na ba?
So there's already power. So when we start the first inverter, so we have say Inay na kayo. Lagyan na siya. So, there's already say, you can see the voltmeter. The voltmeter. Oh. So, full na siya. Oh, fighting na. Oh. So, we can start the fan motor. So, the next is the second inverter. That will be synchronized. It will be synchronized. Perfect. So that what the set point of that one is 80%.
Pangutan na. Kung sa uma, kung unahon ni mo ang fan, o wala sikat motor na wahi.
Hindi mo andar.
Di mo andar.
Hindi mo andar.
Asa tabukang 80%?
80% of the frequency. The frequency is 60 also. One of the 36. So, yun, that's the simple lang. So,
What did what tingog?
Load.
Load na.
mouse, change over. Load.
Sinalan daw nga yun.
Actually, ang kuwan na kasi tagtangan na siya. So, wala na power sa kuwan. So, actually, it should be automatic, no? Pero, ikuan lang mo, kung very sensitive ang kuwan, so kailangan i-off sa una ang kuwan. Ang big. Kaya magsalubong ang power nila. Oo.
Pero ang uhon na itong hinuon na ni, natin ipis.
Na, automatic na siya. Automatic na siya. Completely automatic na siya.
Ay, sumitisan ng gano'n. Load.
Big generator. Supply na sa 1,000 pamilya.
Ang pinanili, which is, you have to take up every 3 months. For the,
Normal na rin. Ito na.
actually, ang kuwan ito, moving part of bearing na yan. Gear niya.
Ang kanyang tilasan automatic kita.
Oo, sige. Dati talaga ito. This one, we will not seal the unit. We will seal the power only. Because if I will seal the unit, abihan na niya, hibangan, yung sample
Ang
namin.
say chances sa overheat ani.
Overload.
Overload. Pero makuha na siya. Kung overload siya, mapatay na siya.
Naman tayo, kung din. Pero na treat of niya, na may thermal. Overload ba? Overload.
Thermal control.
So, kung siya, sugod karon ng kaso-kaso, paandal na ito permit, until December, ay kaya, why problema? Until December, 2027, and 55 days.
Taga nito, ay
Dili ta makuha ng spare or something. Hindi ko din siya.
No, actually, when we supply, for example, 100 kilowatts ang pinahanda, supply natin ba kamo? Because ang kuha na to is 24/7, 365 days. Kung mag-preventive maintenance or there's a breakdown, so ang isa automatically spare. Yeah, wala pa saba.
Kunya i-cross na nato ang mga kuwan dito sa Saudi, ang mga wheel nila.
Ha? Dili, ibumbahan natin.
I-cross na nato ang wala na oil.
Wala na.
Wala na tulo.
Tapos kita dili,
Wala yung nagamiton.
kita dili mag-ilinyo ta, na ilinyo, wala na kay ano ta sa kuan subsupon, buhat ang isang lisong ta, tapos wala ko rin kuan electricity.
Naman, hindi ka rin ito na.
Oo. Kuan. Kaya nila mag-disination dito kay kuan man, kay naman sila kurente, barato na kurente nito.
Kaya karon, ipigor nato sila.
Oo. So, ini, mahimo na rin siya.
Wala na si Pinko.
Wala na.
Wala na.
Wala si Pico.
Moving on its own.
Wala na yung son. Yun, nagsigal na siya.
Ano na aircon.
Yes.
Kaya ang usual naman, kung tawag pila yung load,
Yes. Para ma-kuhan ko kung pila ang supply. Kasi ang supply natin, this one is 2.2 kilowatts, drive 12 kilowatts. The next is 5.5 kilowatts, drive 20 kilowatts. and then 15 kilowatts drive 55 kilowatts.
Dito ka.
Oh, so,
Ano po? Gigawatt. Kuha man, barangay. Tigok taon.
oh, equal sa niyo kung pila kabuk sa kuwan. So, muna ito supply. What yung supply. And then, we will meet first partnership. Just give us finance to, just only for start.
At pinan. Approve
Oh.
na. Approve na ang finance nimo. Emilio.
Pero sa aman,
Kung sa kuno.
Balik pa na yung anong gano'n.
I-discuss sa board. Ito, kailangan nakaka dito.
I will post na finger na kuhan. Ballpen.
asa man ito sa Santa Fe.
Asa, dila lang sa Cebu. Cebu ang board.
Pero maayo mo tayo sa tabi.
Nindot na sa tabi kay
Asa tabi na lang.
Pasabti sa nata niya.
wala.
Wala sa test. Kaya yung sakyan na, diretso mo na
Dito na lang ito.
Wamay dito.
Dito nagikan no. Karong Bernes mato na po
Balik
ko.
kong Berlin.
Dungan po ni.
Dongan ta! Hindi ito, internet kayo.
At may istorya ito, pati ito may kaisama.
Muli.
It's revision for a great revision power permanent magnet generator, small input drive the bigger output and power by itself. So the 2.2 kilowatts coupled with the first gearbox and then coupled with the second gearbox and drive the 12 kilowatts. Okay, so this is our single line diagram.
Single line.
Single line diagram which is submitted to the patent. This is figure 3 in the patent and this one is hook up drawing a figure 6 in the patent. So when this one running, we have a voltmeter here which is genset line 1, line 2, line 3, that is 220 volts AC, and the other one is 3-phase 380 volt AC. So now when we start this one, we have two variable frequency drive. First is to start the motor, and then second, if this one is running, that will be take over the second inverter. So there is no power here. Okay, when we start, there is no power. So we'll just put a power here.
Walang genset.
So plug-in type lang siya. Okay.
Nagasaksak?
Asa may saksak na.
Ako lang eh.
Paigo lang siya pagpa-ignite, pagpa-under lang sa motor para i-drive ang generator mo.
Dili isaksak mo sa taas, sa taas isaksak.
Create na po siya power
Oh.
dere. Vice versa,
Wala
independent
nga kurinti ana.
mo create na po siya og kuan motion independently then ibalik kuan kini mo drive na po siya.
Okay na.
Murag
Yan,
generator
naisuga.
na power. Gibantik sila.
Tumuoron ni siya kada kada
Dili kay kung dako
Okay,
depende
power.
man kapitan ang required sa kuan ibutang
Okay, now we have already a power from Sibico. Okay, so we will start the first inverter. So the first inverter is already power. So we start this one. So this one is running now. This is a low speed and high speed. So you can see the voltmeter goes up. That will be, it goes to 220 and the other one is 380. So when we have a 380, we own the fan motor because the fan motor is a different motor. This is independent motor. So this one is like a blower for the cooling. Right. So now we have to synchronize this one. We set this one to 80%. So this is the, if this one synchronized,
3610.
yeah, that is the frequency. Frequency. Okay. You
Ito na ba? Gibot na.
Combine now. We didn't want to
Kantanga. Kantanga.
Wala na siya anong power so parada na.
So no more power.
Wala na power.
No more power.
Okay, no?
This one is it will take 10 seconds and then the trail will be off. So
Wala na power. Wala na power.
So no more power from the Civico. This one
Wala na
is
si Miko.
power by itself. Nagtutuyok na lang ang power. Okay? So, now we put a load. This one is 500 watts each bulb.
Kung saan na?
Oh. So, it's a power
Wala
now.
na kay consumption na. Wala na kay mabalik.
Oh.
Wala na kay gasolina.
Wala tanan.
No, this is purely green energy power supply. Purely green energy power supply. Now this one, our model is 5.5 kilowatts, drive 20 kilowatts, and then 15 kilowatts, drive 55 kilowatts, up to 6,500 kilowatts. So from small scale, which goes to for the household, we can until we can also for the large scale supply, we can take it out the feedstock of the power plant, the coal-fired diesel engine. We take it out that one, so we're helping our environment. So this is the one we
Green energy.
purely green.
Why kurente na?
Why kurente di jawi na? Sisilang ka na 500 watts? Sige na.
So, pinisin ko lang.
Pero still, kinanglan niya po na itong si Biko.
Wala na kayo magkuhan nga ta.
Pag-start lang.
No, for this one, but because we have to use the battery back, so it is quite expensive. That is $15,000 for the charger inverter and the battery bank.
Mahal to.
Oh,
Pero condenser type ang kuan na battery bank niya.
Kuan, yung normal sa battery sa 12 volts. The 12 volt, that is 32 pieces.
Ang storage ato sa para sa consumption sa power is condenser type.
That is inverter lang, which is to invert the DC to AC. Converter.
Para
Pag-start lang. Pag-start niya, and then, if there's already a power from the generator, so there's already
Tanan.
Tanan.
Kung kala siya, mukhaon ng kuhan.
Ano Mercury ba ni? Mercury na. 200 ba siguro?
500.
500. Pila ka buok?
to satisfy
1, 2, 3, 4, 5.
Kaya ang power ang nito gikan man sa sa